All right, welcome to the Desert Blockchain monthly session. And we are at Gangplank Chandler. It is Wednesday, October the 28th, 2015. It's a little past 7 o'clock. And we're going to be talking with Greg
Slepak.
I'm sorry?
Greg Slepak.
Slepak.
Mm-hmm.
I actually practiced, so. Greg's joining us from the San Francisco area, and we're going to be talking about OK Turtles Foundation, DNS Chain, maybe Blockchain ID, and some other great projects that Greg has going. We also have Ed from Prescott. Ed, are you there? All right. Well, Ed is showing here. I assume that he's muted. In addition, we have Sheldon and Jason and Gavin and Mike. So, all right. Well, Greg, let me turn it over to you. And basically, this is just going to be kind of like a question and answer session. You've got a lot online where you talk about the man-in-the-middle attacks and all the security flaws and all that stuff. So if you want to do just a very brief introduction of OK Turtles, DNS Chain, maybe Blockchain ID, that would be great. And then assume that these folks understand the man-in-the-middle attacks and all that sort of thing. Does that sound good to you?
Yeah. Totally sounds good. So, where to begin? Right now, I guess we could start with online communications and how those usually take place. Most online communications seem to be taking place today through web browsers or through mobile devices and apps on top of them. And the technology that's used to secure those communications, whether it's on mobile devices or whether it's on your desktop through a web browser, it's the same. It's called HTTPS. And more specifically, what the S stands for is secure, and that comes from wrapping HTTP within a protocol called TLS, sometimes also referred to as SSL. SSL was the original name. And then after SSL version 3, they released an update to it, and they changed the name from SSL to TLS, Transport Layer Security. And since then, we've been using TLS. So the challenge here is, how do you establish a secure channel with somebody that you want to communicate over the internet? And when we first started doing cryptography, when humans first started doing cryptography, the first serious form of cryptography was referred to as symmetric cryptography, one of the first. And that was for encrypting data when you had a shared secret. In other words, when you and some other person knew some sort of secret piece of information, then the two of you could use that to encrypt arbitrary messages and send them back and forth in a way that nobody in between the two of you can read that communication. So when you encrypt a message, the result of that is called ciphertext. And when you decrypt a message, the result of that is called plaintext. Well, this method, symmetric cryptography, symmetric encryption of data, was not very convenient for doing online communications because people can't establish shared secrets with people they don't even know. So the solution to that came later on, and it was called asymmetric encryption, or also referred to as public-private key cryptography. And the idea there is that you actually have two secrets, except one of them is not secret. One of them we refer to as the public key. And the other one, the actual secret, is referred to as the private key, which can be used to identify entities. So that pair allows you to encrypt a message to somebody else, knowing a piece of information that everybody else knows, in such a way that only they can read the message. That's much more useful, and that's the basis That's the cryptography that's used to encrypt virtually all online communications today. And that's what TLS uses. The challenge is how do you get the right public key to the people who want to communicate with you? If you can't do that, then an eavesdropper, often the name used in thought examples is Eve. So if Alice and Bob want to communicate, there's an eavesdropper called Eve, who can be in between the two of them. And as they're exchanging public keys, Eve can swap their public keys out for her own. And thereby she has the ability to decrypt and re-encrypt messages. And that's what's called a man-in-the-middle attack. That's an example of one such man-in-the-middle attack. So the inventors of SSL were aware of this problem, and they tried to address it. And the way that they decided to address it was through the creation of authority figures that the entire world would trust. These authority figures were called certificate authorities. And they devised a specification, and they gave it the name X509. And to this day, we're using that specification that they came up with. And that's the authentication part behind TLS. So TLS is really composed of two parts. One is the tools for encrypting messages, and the other part is the protocol for authenticating those messages. Those are two very different things, encryption and authentication. Encryption is just making text unreadable, but it's not very useful if you don't have strong authentication. Authentication is, in other words, being sure that you're talking to who you think you're talking to. And many protocols today, like most of email, in fact, is not authenticated. It's encrypted, but it's not authenticated. And that makes email very simple to read for, to conduct mass surveillance on, transparently, and in a passive way, in fact. Sometimes these attacks are referred to as active man-in-the-middle attacks, but I don't think that's very accurate because there's not much activity involved in the decryption of email. You can do it totally passively. All you have to do is be on a node on a computer that's near the hub of the internet, somewhere close to an ISP or near the internet backbone. And with a piece of hardware, you could easily do passive man-in-the-middle attacks, de-encrypting and re-encrypting messages, because none of these public keys that are being passed around are being authenticated by anything with email. In the case of HTTPS, they are being authenticated by these certificate authorities I mentioned, of which there are on the order of about 1,000 of them or so, as somebody did a survey of them. Browsers ship with on the order of 200 what are called root certificate authorities. But these root certificate authorities have the ability to give other entities called intermediate certificate authorities the same powers that they have, which is, in other words, the ability to sign people's public keys in a way that gets browsers to trust them. And when you add up all of the root and intermediate certificate authorities across different browsers and different operating systems, the number goes well over 1,000 entities that the internet is trusting. And this is not a good situation because the way that it ends up working is that the more of these there are, the less secure the entire internet becomes, because you're not trusting, one way to say it is you're trusting all of them, but an even more accurate way of saying it, is that you're trusting, like you take this group of 1,000 entities and you try to find who is the least competent and the least secure, and that entity is the entity that determines the security of the entire internet. Yeah, so that's the problem that we have today, and that's the problem that DNS chain and blockchains can address.
So, Greg, I think you also in your videos you make an excellent point that not only are you trusting, or your level of trust is the lowest common denominator, or lowest certificate authority, but you're also trusting that they are secure, that they haven't been hacked into.
Right, yeah.
And I think that's a huge consideration, because if there is a compromise of any of those 1,000+ certificate authorities, they're all compromised.
Right, yeah, that's an excellent point, is that, that's what I mean by not just how trustworthy they are, but also how competent they are. So if they're not very good at securing their systems, then a hacker or anyone can potentially a disgruntled employee could spill their private keys, and those can be used to compromise websites. They can also be coerced by various different governments. Recall that the computers that you guys have in that room, uh, those laptops are trusting companies that don't just reside in the United States, but companies that reside in China and various different countries as well. And to be honest, nobody, nobody in that room, nobody in this room, including myself, knows who my computer is trusting. And that's a very dangerous situation. Why would we put ourselves in that situation? It's nonsensical. Why would we say let's make it so that the security of the entire world depends on people who we don't know who we're trusting? That's exactly the boat that we find ourselves in right now.
Yeah, I think you're preaching to the choir here. I think every time I mention that we were going to have this session and we we're going to be talking about alternatives to certificate authorities, there were great sighs of exasperation and concurrence that there's a huge problem here. So I think what you're introducing with the DNS chain and the blockchain ID, I think is very, very interesting. So if you could talk about those elements, how they work a little bit, and then we can take some questions from the folks that are here. So.
Sure. So to talk about DNS chain and blockchain ID, I should first talk about blockchains in general and what those are. So I can give a real quick overview of the idea of a blockchain. Sound good?
Sounds good.
Okay. So a blockchain is basically a database that the entire world agrees on. I mean, usually, the blockchains that we are familiar with. There are private blockchains that are kind of, some companies are looking into right now. I'm not referring to those. I'm referring to public blockchains, like the blockchain that powers Bitcoin, or the blockchain that powers Namecoin, and the blockchain that powers Ethereum. Those are public blockchains that anyone can participate in the consensus process of building those databases. And the way that the consensus algorithm for those works is that it makes it possible to agree upon a database that is secured by arbitrary participants. So in Bitcoin, you don't need anyone's permission to participate in the consensus process. That actually is somewhat changing since its launch. Right now, it is centralizing a bit in the whole Bitcoin blockchain space. And many blockchains may evolve in this kind of semi-centralized way. They might start out really decentralized, and that's how Bitcoin started out, where anybody with a computer could participate in the consensus process. And then they, for whatever reason, may start centralizing. One way that people can still participate in the consensus process of Bitcoin is by joining a mining pool, where individual computers, if they're mining on their own, are not able to ever have a chance of producing a block. They can actually add their voice to the consensus process by joining a mining pool. So what these miners are doing is they are, in the case of Bitcoin, they're using an algorithm called proof of work to come to agreement about what the state of the blockchain is. And the way that the algorithm works is that the more blocks they produce, and they produce a block about once every 10 minutes, the more secure the information that's already in the blockchain becomes. Because anyone who wants to undo all of those blocks and all of the information there has to redo all of that work. So the farther back it gets pushed, the more secure it becomes. That's the basis of proof of work. And proof of stake, something that Ethereum is planning on switching to, works differently. That we should probably not go into that because that'll take a long time. So that's the general idea of a blockchain, is that it's a decentralized, secure database that anybody can participate in securing and agreeing upon. And that's it's also economically incentivized. That was one thing that Satoshi did with Bitcoin, was that he created the rules in such a way such that the economics and the game theory of it encouraged people to play by the rules. And he was able to create a system that was, without any central authority, capable of allowing any person to create an account and send payments from one place to another, which was radical. Totally radical because, well, first of all, it just had never been done before. All of the payment systems that predated Bitcoin all involved some kind of central authority. And anytime it's kind of like the Napster days. When you have a centralized system, it's easy, it's a central point. Think of it. Centralized systems are effectively central points of failure. So they're easy to shut down, they're easy to censor, they're easy for whoever has the biggest gun to manipulate. Bitcoin's a totally different beast in that sense. And the very first fork of Bitcoin was something called Namecoin, where they took the idea, so the idea that I'm referring to right here is this idea that blockchains make possible, which is the notion of ownership of digital property, which is something that, again, did not really exist in any meaningful form prior to blockchains. So most people are used to the concept of ownership in the real world. Most people are used to the idea that, oh, they own a car, they might own a house or something like that. But online, that concept of property did not exist for a very long time, until the blockchain came along. Because what people really did was with their websites, their domain names. Say you have a company and you register a website. Well, you don't own that domain name that you get when you go to a registrar and purchase it. It's not really yours. Somebody can come along who you don't know, and if they disagree with you, take it from you. And this happens all the time. This is called domain seizure. And it's used to censor websites that are unpopular, etc. Or I should say, are unpopular within some kind of a group. So they might even be popular, like in the population. Like for example, the Pirate Bay is a very popular website around the world, but those in power don't like it, so they try to censor it by seizing those domains, and they've done that multiple times. So the blockchain, and similarly, not just domains, but individual identities. Nobody owned their individual identities. So, people thought that they did, but really they don't. And they realize that when their identity gets shut down, like on websites like Twitter and Facebook. Only then did they really realize that, oh, I never really owned who I am online. This other company called Twitter or Facebook really owned me. And they always kind of like had their thumb on the button, and they could always press it and take who I am away from me, my voice. And that's a dangerous thing when people's voices can be silenced with the press of a button. So Namecoin came along and changed all that. Namecoin took the idea that Bitcoin introduced of being capable of actually owning your finances in digital form. And it said we can use that technology to allow people to own their identities. And so that's where blockchain ID comes from. Blockchain ID is just a specification, a format. It's basically some JSON format that you can store in any blockchain. And because you own the private key that controls the access to that information, only you can update it, and nobody can shut it down. Asterisks, unless there's a 51% attack taking place, that kind of a thing, which is the standard attack on blockchains. And with DNS chain, the idea there was that, well, these blockchains are like heavyweight beasts. They're kind of like, the way that I like to think of blockchains is there are two network-wide data structures on the internet of note for doing decentralized data. One is the blockchain, and I like to refer to that as the internet's long-term memory. And it's kind of heavyweight. The other one is called distributed hash tables, DHTs. This is the technology that powers BitTorrent. You can think of those as short-term memory, the internet's short-term memory. So the long-term memory is fairly heavyweight, and it's not simple for a device like my phone to run a blockchain. And so the idea with the DNS chain was, how do we allow these phones and these mobile devices and these laptops to be able to quickly and securely communicate with blockchains and access the information that's inside of them and update them. And so DNS chain effectively is just a way of doing that. It's like a translator for different protocols to talk to blockchains. It speaks DNS, it speaks HTTPS, and you can use those two protocols to read and write potentially. Currently, we only have reading enabled, implemented from blockchains. Now, it does the way that we currently have it designed is that you do have to trust the DNS chain server that you're using, which means it's most secure if you run your own on a server somewhere. If you don't have your own server, we recommend trusting somebody that you know or you feel is trustworthy. And if you don't have somebody like that, then querying two independently run DNS chain servers and comparing those results. And in the future, right now we're starting to push this concept of thin clients. And thin clients are, the idea behind them is that instead of storing the entire blockchain, they're protocols that allow you to store a small piece of the blockchain. And just enough to be able to verify that, to give you some reasonable assurance that the information you're getting using this protocol is secure. And they're great because you don't even necessarily need to know of somebody who's running like a DNS chain server. You can kind of connect to this decentralized network and query multiple different servers and get proofs that, for example, in Bitcoin, a thin client protocol is, there's one standard thin client protocol that is actually implemented today, and it's called SPV. It was described in the original Bitcoin white paper by Satoshi. It stands for Simplified Payment Verification, and what it's capable of doing is just giving you assurance that given a transaction, that the blockchain has accepted it. So I think I covered DNS chain and blockchain ID.
Greg, about how many, do you know how many DNS chain servers are out there now, currently operating?
I actually don't. No, we don't have them phoned to a mothership. We do. There, you can look at the download stats on NPM to see how many installs there are. Sometimes people do tell us, and we actually have a list of servers that people have told us that they're running. But I honestly don't know how many DNS chain servers are running out there. No.
One of the things that I think is really, really powerful with the DNS chain that you're doing is it opens up the ability to create a hybrid ecosystem that uses both the blockchain ecosystem as well as the, I'll call it the incumbent DNS ecosystem. And so I'm, I don't know if you could share what other people are doing in terms of, a hybrid configuration where they're using, sort of the best of both worlds, or they're giving people a choice. Would you talk about that?
Well, I do know one company mentioned that they were using DNS chain called CryptoStorm. They're a VPN provider, and they have a DNS chain server that their network supports DNS chain. As far as other servers, I know that there are other servers that are implemented that are kind of DNS chain-like. They serve the same functionality. They're just not either. They might be more far along in one aspect and not as far along in another aspect as DNS chain. So I know that some of the there's one Namecoin developer who's working on a Go implementation of a server that's like DNS chain. And one advantage of his Go implementation is that it fully supports the Namecoin specification. Ours, DNS chain, does not yet fully support the Namecoin specification. We didn't put much effort into that because we felt that, well, for a variety of reasons. First of all, we prioritized blockchain agnosticism. Like we are pushing that heavily. It's very simple in DNS chain to add support for any blockchain. It's basically you copy paste one file and you modify a few methods in a class, and then DNS chain, all of the features of DNS chain become available to that blockchain, including DNS and the RESTful HTTP API. So we prioritized that. The one name folks had a feature, they wanted some caching stuff, so we added support for Redis and caching both DNS replies and the RESTful replies. Um, and we didn't support fully the Namecoin specification. Well, because there are not that many people who are actually using the Namecoin specification today. So why support it? We just supported the bare minimum of the Namecoin specification to be able to resolve .bit domains. But it's a waste of time to support the whole thing if nobody's using it. So yeah, but if you want, a fully supported Namecoin specification server thing, then you can go ahead and use NCDNS, I think is what it's called. And I think the Namecoin developers are kind of putting their efforts behind that project. At least that's what I last heard. At the same time, Namecoin isn't doing so well. Some of the developers are leaving the project to work on their own things. The OneName moved their whole system off of Namecoin and onto Bitcoin because they felt that Namecoin was not secure. They showed some graphs showing that there was a single pool that had 50% of the hash rate for like months and probably still does. And then there was one other pool that had 20%. So there were basically only two pools mining this thing, and one of them had 50% for months and probably still does. So that's not. They felt it was very insecure, and they also felt that there wasn't enough development effort behind Namecoin. So they created Blockstore, which is a way of doing this stuff, a way of turning Bitcoin into an arbitrary key value database, which you can use for doing Namecoin. And that's what they're currently focused on. And they also have their own OneName specific, blockchain resolver server. So you can look at the repo and find it's written in Python. So if you're a Python aficionado, like oftentimes that's one of the reasons why these projects are chosen by a group is because they've got developers who prefer one language over another. So if you really like JavaScript or CoffeeScript, go with the DNS chain. If you really like Python, have a look at the Namecoin resolver. If you really like Go, have a look at what the Namecoin folks are doing with NCDNS. And really, we're not a for-profit company that's trying to push a product. What we're trying to do, we're a nonprofit that's pushing an idea. We see a huge problem on the internet, and we're pushing an idea, a protocol, to be implemented by many servers to fix internet security. That's our goal. Our goal is not a million DNS chain servers. Our goal is a secure internet.
So hey, I got a question. You kind of mentioned three different concepts. One being the issuers of SSL certificates. The other being, say, DNS registration, and the third being identities. Can you clarify, which system does what? Like, is Namecoin the DNS, or is Namecoin to do identities, or is Namecoin to do SSL, or does it do all three, or just kind of clarify.
Namecoin?
Yeah.
Well, I think
it's DNS chain,
right,
or blockchain ID.
Right. So Namecoin and DNS chain, I would put kind of like, for the purposes of this conversation, in the same bucket, and just put them in the bucket and label the bucket blockchain. What is the blockchain useful for in terms of the three things you mentioned were SSL, DNS, and identities. Well, it's useful for all three of those things. SSL, well, SSL is just for securing internet connections. That's its function. That's what it's trying to do. DNS, that's the system for simply mapping names to IP addresses. And blockchain ID are the identities themselves. They're identities. And so a blockchain ID is actually very separate from the first two. It has nothing to do with IP addresses. It has little to do with mapping domain names. It has more to do with security in some sense, but really it's about owning an online identity. That's what blockchain ID is about. I'm not sure if I answered your question.
Yeah, you did. I mean, I'm familiar with what DNS is and familiar with what SSL is and familiar with identities, but I just wasn't sure the context of those on these blockchain, contexts.
Right. Well, the blockchain context is that it's an excellent tool for addressing all of these problems. It's a tool that lets you address the problems that SSL, or rather X509 is trying to address, and DNS is trying to address, and it addresses both of them, and it does it better than they do.
Kit, go ahead.
Yeah.
Yeah. So a client, say a browser and app or whatever, instead of doing what we have now, our PKI SSL, it would leverage DNS chain. That communication, how would that take place? Would that be doing like RESTful HTTP with TLS, or like how does that? How am I as a client querying a DNS chain server to validate, the server, like who they claim?
Right. Yeah. So that's what we refer to as one pin to rule them all. So you would be using HTTPS, but you wouldn't be relying on, whatever client software you would use. Like you would have to actually use some SSL library out there to authenticate the connection without X509. So basically, it's kind of like, a self-signed certificate. Are you familiar with that concept?
Say that one more time. Sorry.
Are you familiar with the concept of self-signed certificates?
Yeah. So it would be a pinned certificate then. Yeah.
Yeah.
Okay. Got it.
You would pin the certificate of the DNS chain server.
What did you term that as? One to rule them all? What did you term that?
Yeah, we like to call that one pin to rule them all.
Okay. All right. So
because you have this one pin to DNS chain, and if you trust the DNS chain server, you can get, it's as if the certificates of all the other websites and identities are pinned in the blockchain.
But,
so you've got this one pin that gives you access to all these other pins.
Gotcha. Okay. That makes sense. Just a quick follow-up. Would that itself be self-signed X509 certificate, or would that be a blockchain of some sort?
Are you talking about the certificates that are stored in the blockchain?
In the client. In the client. This one cert that you have pinned in the client.
Would that be a self-signed certificate? Is that what you're asking?
Yes.
It doesn't have to be. It doesn't matter. Like all you need to do is, like, it could be self-signed or it could be not self-signed. Our DNS chain server certificate, if I recall correctly, is actually signed by Start SSL, which is a company that issues free SSL certificates that browsers trust, which is why we chose them, because they were really the only option for a free SSL certificate that's trusted by browsers. And what is relevant is just, the SSL fingerprint. It doesn't matter if the certificate is signed by somebody or not. The reason why we had it signed was so that people can just, in their browsers, for demo purposes, type HTTPS, api.dnschain.net, and visit all these things, and it would show a little lock icon in their menu bar, and they wouldn't have to see that screen, oh, this is not a secure connection because it's self-signed, that whole concept of whether or not a connection is secure or not because it's signed or not is just like, that'll all go out the window. Hopefully, if browsers adopt blockchain technology, you're not going to have to deal with that because there aren't going to be any of these other third-party authorities to sign things. But so we just did it for convenience. That's why we signed it. In other words, it doesn't matter. You can, like, if you want to implement an app, and you're implementing this, like, on an iPhone, and you're using the SSL TLS APIs, in the background, you can do it however you want. It can be self-signed or not.
Gotcha. Thanks.
Yeah.
So, Greg, would you talk a little bit more about blockchain ID? Where is that at in development? And, what are some of the interesting use cases that you're seeing emerging?
Yeah, blockchain ID, we've partnered with OneName, and now OneName is running with it. So the blockchain ID repo, I need to update it. There's an open issue for me to update the repo to say, hey, blockchain ID is now being done by OneName. But basically, I chatted with them, and they're running with it. They've totally adopted blockchain ID. Ryan Shea is going around doing talks about blockchain ID. He's implemented a library called Blockchain Auth for using blockchain ID to authenticate through apps and through websites. And they've created a full-blown specification for blockchain ID that we approved the JSON format for it. At least at last glance, I don't know. They might have changed it, made it worse or something. But we're trusting them to run with it.
So, and is OK Turtle sort of the mothership for DNS chain and then blockchain ID and whatever else comes along? Is that sort of your structure?
OK Turtles is the mothership of different projects. Yes.
Okay. All right. And how many do you know how many identities are in blockchain ID right now, approximately?
Yeah. Well, because OneName is sort of rebranding all of their identities to use. Also, they're actually probably using the format for blockchain ID. They have on the order of 30,000 identities stored in that format.
Okay. I'm gonna follow up from Jason's question. So right now, I trust an SSL because I have a bunch of CA certificates in my, certificate store, and I can follow the chain and say, oh yeah, it's trusted because this guy issued it, so I trust it. In the case of it going away and being blockchain based, would my client, like my browser, have to have that whole blockchain, like a local copy of it? Or, just like the Bitcoin concept, if I go to transact in Bitcoin, I don't need to have a copy of the blockchain. I rely on my exchange or my wallet to do that. But in the case of a browser, it's definitely a client-only function. So how do I trust anyone? Because whatever I use to go out to someone can be intercepted, right?
Okay, so that's the whole idea of DNS chain, is solving that problem. That's like the problem that DNS chain solves. As I mentioned before, DNS chain, the inspiration for it was how do you get devices like this to use the blockchain securely? So we started working on DNS chain, and it's a secure proxy, a secure window into blockchains. You've got a DNS chain server running out there, and it's talking on the same machine to a Bitcoin full node. And if you have a secure connection to the DNS chain server, you now have a secure connection to Bitcoin without your laptop or your browser running Bitcoin. And to push the envelope even further to make it more secure, in the future there can be thin client protocols that allow you to securely, to get certain kinds of proofs that information actually exists in the blockchain, or etc. And those are just a ways away. So for now, those might be years away. For now, the best thing to do is to query two independent DNS chain servers, or query one that you run yourself.
All right. Does that answer the question?
Well, it's still, that initial trust request, how do I know who to trust? Unless we exchange public keys to start.
Well, not only that, but
I'm trusting SSL.
Normal people aren't going to run their own, normal people aren't going to run this themselves. So at some point, normal people are going to trust, like Verizon. Like maybe whenever you're using a Verizon phone, you're using Verizon DNS or something. So you're using the Verizon
or they have a chain node
of their
server.
DNS.
Well, they could trust Verizon, but they could also, it's a different mathematical function from X509. In X509, as Jay very eloquently said, you're trusting the least common denominator. You can't actually trust Verizon with X509. You can't actually trust, even though the name Symantec and VeriSign appears in your trust store, you cannot trust them. X509 doesn't let you trust them. X509 only lets you trust the least common denominator of those 1,000 or so authorities. Some of which don't even appear in your root trust store. They're intermediate authorities, so you don't know who you're trusting with X509. That's a huge difference from with the way that DNS chain works, where it's an AND function. where you're trusting, you know exactly who you're trusting, and you can always add more trust. So you can say, well, I'm going to trust, Apple's running a DNS chain server. I'm going to trust Apple, and I'm going to trust, their arch nemesis, Microsoft. Surely the two of them won't, if we were asking both and they disagree on something, I want to be alerted on that. They're not going to collude or something. In other words, you can run your own DNS chain server. You have that option available to you, whereas you don't have that option available to you with X509. And once thin clients come out, you don't even have to think about this stuff. You're not going to be trusting Verizon. You're not going to be trusting Apple. You're not going to be trusting. You don't even have to trust a server that you're running. With thin clients, you can actually have your web browser connect to the blockchain peer-to-peer network itself and store little bits of information that allow it, like in the case of Bitcoin, it's storing just the blockchain headers, which are very small in size, and they allow it to verify that a transaction exists in the blockchain. So that's the, what is it? I don't know, like the golden egg or something like that. The ideal. That's the limit of this technology. That's the best that we can get, that we know of, to do with blockchain security.
So I'd just like to make a comment for anybody who might be watching this at some point. Greg has done numerous talks that are available on YouTube, and I just watched about 2 hours of a session with the Blockchain University, which is in 2 parts, and Greg goes through many of these items in detail and does a great job of explaining it. So I would highly recommend you watch those videos if you're interested in this. But one of the things that I really walked away with is that, like the blockchain, the responsibility gets pushed out to the edge. But with what you're talking about with the DNS chain and the blockchain ID, is the choice gets pushed out to the edge too. So instead of us having our trust ecosystem dictated to us, we get to choose. We get to be responsible for our trust choices. So I think that's a really key point out of what you're working on, Greg. Anything?
You're absolutely right about that. That's also a very eloquent way of putting it. That's kind of what decentralization does in general. Is that it takes power that was formerly concentrated in a center, and it spreads that out to the edges, as you say, and that's what blockchains do. And that's a very powerful concept, because it. I think it's a concept. If there's a political element to this, it's one of those rare concepts that I think both like the left and the right can agree on, because the left is often very concerned about personal freedoms and liberties, and the right is often very concerned about personal responsibility. And this is a case where those two, you can see both of those elements.
Absolutely. And I think part of the beauty of what you're introducing with DNS chain and this ability to do a hybrid implementation between what we currently have and what we could have is that there's a whole realm to experiment with what actually works for people, because some people don't really want to take that responsibility. They're used to having the responsibility vested within some sort of central authority. So what I see with DNS chain, and I don't fully understand blockchain ID at this point, but I see this rich opportunity to really experiment and have developers, have people create some use cases and systems where you can put it in people's hands and see what actually works.
Yeah, and exactly. And there's even one more thing that what you're saying just brought to mind. And that's that, right now we're kind of very much focusing on the edges, but let's step back for a moment and focus on the center. We've got, companies out there, very centralized companies like Facebook and Twitter. Do they have anything to benefit? Do they stand at all to benefit from this technology, or governments? And in fact, yes, they do. And one thing that they have to benefit from is lowered liability. So, hospitals and insurance companies and lawyers and governments, they all have to deal with private personal information, and they have to deal with the responsibility of keeping that information secure. And we, recently, only a few months ago, had a government data breach where all of the, people who passed through the government's or the application process for getting a secure security clearance had their personal information hacked and revealed online. These technologies can prevent such incidents. So, Twitter right now is like a ticking time bomb with the messages that it has that on their servers from people direct messaging each other. And the same goes for Facebook. It's also a ticking time bomb. At some point, if they don't address this problem, they're going to get hacked. And all of a sudden, all of these direct messages that have, who knows what kinds of personal information is going to just be out there in the open. And people's finances can get hacked. They can log into their bank accounts. Their websites can be destroyed. All kinds of bad stuff can happen. People will be very upset with Twitter or Facebook if that were to happen. So if they want to eliminate that liability, they can give people control of their identities. And by doing so, by giving the private keys to the individuals themselves, that information can be kept away from them. It can be encrypted. And then the responsibility is placed into the user's hands for keeping their communications secure. And it's no longer the company's responsibility.
So was the internet more secure back when there was only VeriSign as a CA and that was all there was? Was SSL good enough back then? Did decentralizing that and making it so that there's 1,000 different companies, is that part of the problem?
Well, that's actually a very interesting thing to look at. It's very interesting because on the one hand, you could say that it was decentralized, that you had the system and it has all of these different CAs, so many of them. It seems like a decentralized system. But actually what we did was we centralized trust. Even though it looks like the system is decentralized, what we did was we centralized the entire Internet's trust in what Jay calls the lowest common denominator. That's the effect of that system. Everybody on the whole Internet is trusting this one entity, which can be actually at any point in time, a company in China, it can be a company in the United States, whoever gets breached. But that's where it's trust that was centralized by X509. So that's what that system does, is that it centralizes trust no matter how many CAs there are, whether there's one or whether there are a whole bunch of CAs. If there's only one CA, it's still a problem. X509 is broken no matter what you do with it. Whether there's 1,000 CAs, it's broken. If there's a single CA, it's broken. Because what happens if there's just VeriSign? Well, if there's just VeriSign, you've just created the biggest central point of failure and the biggest target that there can be. There's just this one entity that needs to be attacked to compromise the whole Internet. And everybody knows what it is. And then you've added this huge problem where if you do that, you are not just compromising the security of the Internet, but you're also making it super simple to censor the entire Internet. Because if you want to be able to connect to a website over HTTPS, then currently you have all of these certificate authorities are involved. If there's only one certificate authority, then effectively the ability to access websites has been placed into the hands of whoever can control that one entity. And this is true no matter where you are in the world at that point. So if you're in China and you try to access a Chinese website, well, if the one authority that everybody's trusting is in the United States, then the United States government could, prevent Chinese from accessing what's the most popular Chinese search engine?
Baidu.
Baidu, yeah, they could prevent the Chinese from accessing Baidu, and it would that would be a huge problem. Nobody would be happy about that, because the same could happen with the United States. Yeah.
Go ahead, Jason.
Yeah, thanks. So you have a bullet point on here that says prevents DDoS attacks. Could you elaborate on that briefly?
Yeah, sure. There's this, and actually, I think we can go maybe to 8:15 if you guys still have questions.
Yeah, about that. So that'd be great.
Yeah. So that bullet point, I didn't get around to elaborating on that, but I did put a link to I hyperlinked. If you click on that, it says to do see OCSP. OCSP is an acronym. I don't know what it stands for, but it's this. What's that? Sorry, what?
Online certificate status protocol.
Okay, maybe, yeah. If you know that for a fact, then yeah. And it's I do know what the system is for, though. If a website's certificate gets compromised, if their private key is compromised, an individual website's private key is compromised, as happened when Heartbleed came out, for basically all websites on the internet that a hacker attempted to hack, then the proper course of action in X509 is to revoke that key, revoke the public key. In other words, issue a statement that says that key is no longer valid. And how do they do that? Well, there's this system called OC. There's two ways. There's CRL lists or something like that. Those ship directly with browser updates. But the more dynamic way of doing it is this, without a browser update, is this OCSP thing. And that is basically a server, like just a couple of servers on the internet that are running somewhere that maintain these lists of revoked certificates. And every time you access a website, if your browser is designed to check those servers for revoked certificates, and the connection to that server is not available, then you can't use HTTPS. Chrome, for example, I'm fairly certain, does not by default check those servers. So if a server gets hacked, and the hackers are using the server's private key to man-in-the-middle connections, then there's no way for you to know that. There's no way for you, like even if the server administrator found out and they revoked the certificate, it does nothing for Chrome. And similarly, I think by default it does nothing for Firefox. And why does it? The system exists. Why is it not being used by default? The reason why it's not being used by default is because it's a highly fragile system. If it were being used by default, all of these websites, every single TLS connection that would be initiated to any device would have to query these, few servers out there. That would slow down internet connections. And if these servers were DDoSed, then that would break the internet. And in fact, like if you can go into Firefox and you can enable OCSP verification and try using HTTPS, there will be moments when you can't access secure websites. HTTPS.
The default was to continue. I don't think any modern browser will not go to the website. I think it'll just trust the cert that it already has.
If you tell your browser to use OCSP and it can't connect to the OCSP server, then it will not let you connect to sites.
Wow. Okay. Not in any of the browsers that I use, but that's.
So there's a setting. You can go in Firefox. I know Firefox has a setting, and you can enable it. And like I've run across this many times myself because I have it enabled. And periodically, I just can't access a website for like some period of time because the connection to the OCSP server doesn't work.
It's a huge problem for like corporate networks that don't want browsers like quote unquote phoning home, because this is another like concern with OCSP.
Oh yeah.
Like I go to Twitter. Now all of a sudden I'm telling whatever OCSP server I'm connecting to, hey, I'm going to Twitter by virtue of the fact that I'm querying, the cert for Twitter.com. So lots of companies block OCSP requests. So
yeah,
in my
privacy concern.
My experience, the default browser will just say, oh well, can't reach OCSP. I'll just go ahead and trust whatever cert.
That is exactly the default behavior.
It's also bad because if it had been revoked, then you're trusting a cert that has been revoked. So that's bad too. But
right.
Thanks for explaining.
Also, Greg, on the DDoS consideration, the blockchain and I'm not that familiar with DNS chain, but you also have the ability to have more control over your connections and your communications. So you can, you can selectively sort of whitelist and blacklist who you want to talk to. Doesn't that enter into the DDoS issue, or are there other considerations?
Well, in some sense, I guess I can see that, yeah, because there's this blockchain out there, and because it's distributed across all these different nodes, it's really hard to DDoS the Bitcoin network. And so, if you're using a DNS chain server and it goes down, if you have a list of other DNS chain servers that you can access the blockchain through, then that is a great way to circumvent or mitigate a DDoS attack, if that's what you're referring to.
Okay. All right.
There was this one other feature of DNS chain that we didn't get around to implementing, but it was from the Unblock project. It was a censorship circumvention tool that Simon and I worked on. We didn't finish it because it required the creation of a browser extension to work with the DNS chain. And Firefox browser extensions are just a nightmare to implement. I'm hoping that they fix that at some point. And they don't make it easy for you to do things like tell it to trust a specific SSL pin. They don't make it simple for you to say use DNS chain for authenticating HTTPS. So for those reasons and more, we haven't gotten around to finishing the browser extension. But supposing that those problems are fixed, this was a pretty cool feature that would allow people who operate DNS chain servers to act as proxies, so that you can, if you're in China and you're using a DNS chain server in the United States, you can transparently access censored websites like Twitter. And what else is cool about it is that the DNS server operator, the DNS chain server operator, would be able to have control over what websites they unblock. They could just have a list of censored websites that they're choosing to unblock, which is kind of neat because they might have ethical objections to unblocking some websites. Say that they want to prevent people from accessing child porn websites. They wouldn't want people to be able to use their server to have child porn going through, being trafficked through them, basically. So they could say, well, we're only going to unblock Twitter, which is blocked in China. We're going to unblock GitHub, which is in China. And what's really cool is that the way that we implemented it, we hide the server name. The server name in HTTPS TLS connections is actually sent in the clear. So anytime you establish an HTTPS connection or a TLS connection to a server, usually the name of the server you're connecting to is actually sent in plain text. It's not encrypted. This is a little detail that most people aren't aware of. And that can be used to censor connections using deep packet inspection. The way we implemented it was we actually put a TLS wrapper around, and we use that to wrap another TLS connection. So the outer wrapper doesn't have that label. The inner one does. And so they'd be able to just type twitter.com in their web browser, and it would load like it would for anyone else. It would be a seamless user experience. And it would go through one proxy. And what else is cool about it is that it only does this for the sites that are unblocked. Like they have a list of sites on their end, a whitelist that they want to send traffic through DNS chain through. And the server has a whitelist. And the intersection of these two lists are the websites that get unblocked for that user. The rest of their traffic, say they're playing World of Warcraft, just goes over their normal Chinese connection. So that's a really nice feature because that's not how VPNs work. VPNs send all of your traffic through this connection.
Very cool. You touched upon DNS chain having write capabilities. Do you have a timeline on when you might open up write capabilities?
No, we don't have a timeline for that. Right now, we're hoping So there is a company, BlockCypher. Like if you want to use a centralized, third party to communicate with the blockchain, BlockCypher is a company that has implemented an API, a RESTful API to read and write from blockchains. Just keep in mind that if you decide to use them, you're going to be potentially recreating the problems that we were trying to escape from. So if you create like a messenger or a client, and a whole bunch of people start relying on their server, well then BlockCypher is going to know all of those connections. They're going to be able to, conduct surveillance on them. And actually, they won't do this themselves. They'll be ordered to by the government with a national security letter, and they won't even be able to talk about it. And they can then also censor connections, and you haven't really solved the problem. But if you want to do this for like kind of testing purposes, to writing to the blockchain with an API, that's a good option if you can't wait for it to appear in DNS Chain or some other open source server. Right now, we're focusing on, as far as development goes, we're focusing our efforts on some other projects that have nothing to do with this stuff. So if writing to the blockchain is something that you really want, then I recommend just helping out with the development of DNS Chain. The source is there. Send a pull request to implement this feature, and we'll review it and accept it.
Well, that kind of brings me to my next set of comments and questions. First of all, do any of you have any questions of Greg before we move on to some other?
Grilled enough.
Yeah. All right. So Greg, I don't know if you know this or not, but here in Arizona, there's a community that's growing and an ecosystem that's growing to sort of bolster the cybersecurity profile and innovation here in Arizona. In fact, there's a cybersecurity warfare range that's in operation right now. So my question to you, and part of what Desert Blockchain is intended to do, is to have not only monthly meetings like this, but in January we'll have a day-long event which is designed to bring people together and spend an afternoon basically in teams hacking and innovating on the blockchain and things like DNS chain. So, and that'll be on January the 30th, by the way, which is a Saturday. But if you had a magic wand, what would you want people to be working on now, looking at, testing, experimenting with surrounding DNS chain and blockchain ID?
We actually have one issue that we have labeled as priority number 1, and we put the rest of our bounty money on that issue, $120 worth, to whoever closes that issue. And it's not even that difficult of an issue to close. We want to get off of this library called native DNS. Actually, it has 2 names. The other one is Node DNS. It's a JavaScript-based implementation of a DNS stack, and it's not being maintained right now. The former maintainer was TJ Fontaine, and he gave me right access to that repo, but I don't have time to maintain it right now either. And he's not even like responding to my messages about handing over development to some other folks who are interested in like sending pull requests and whatnot. So I'm basically encouraging those people to just like fork that library and rename it to something else. But there's another open source, high quality DNS library that we want to use called GetDNS, and so that's what that issue is. If you look in the DNS chain issues, it's the only issue that has a bounty placed on it. And the idea is DNS chain is designed to support different DNS methods. It actually, like the code is modular enough that you can say, like, use this DNS library just via configuration. Because originally there was a DNS API in Node.js itself that didn't let you choose the DNS server you were communicating with that we supported. So the idea is add another DNS method and make it the default. Switch us over to GetDNS. And if you can do that, that'd be awesome because they support DNS really well. It's a C++ based library, which on the one hand it's faster. On the other hand, it kind of C++ isn't the best of languages, but at least it's being maintained. And I think it even has like corporate backing by VeriSign. So for that reason, of all the options out there, it seems like the best one to go with. And then if that's closed, if that issue is closed, DNS Chain becomes a full-fledged DNS server in its own right that is, can compete with the best of them.
Cool. All right, any last comments or questions before we wrap it up tonight?
Like CoffeeScript? I'm just kidding.
Why did you use tabs instead of spaces, man?
Tabs instead of space. Okay, I'll answer both questions. So the reason we use spaces instead of tabs is because it looks the same no matter what the tab setting is. That's why we did that. Because sometimes there can be conversion problems between, if you have it on tabs. One person has their tab settings set to 4, the other person has it set to 2, and they both modify a file, and sometimes things can get wacky, maybe, but really it's just to keep the view the same. That was the reason. I'm sorry if you're a fan of tabs. Why CoffeeScript? Because CoffeeScript is very fast to write code in. It's very compact, succinct. If I was to do it all from scratch today, I might use Babel, which supports the latest version of ES6. If the latest version of Node doesn't support ES6, which is the latest JavaScript, which has all those... Actually, JavaScript itself has evolved because of CoffeeScript. So if you look at all of the new features that are in ES6, the vast majority of them come from CoffeeScript. And that's why I would use it for those features. CoffeeScript is still a great language in its own right, and it makes for really fast prototyping and compact code. And if we hadn't used it, the code would have been much longer and more scraggly. And yeah.
All right. Well, we're pretty close to the 8:15 mark. Before we wrap it up, I would like to let everybody know that we are having these monthly sessions for Desert Blockchain from 7 to 8:30 p.m. here at Gangplank Chandler. The next one, and it's going to be on the 4th Wednesday of every month. So the next one will be November 25th, just before Thanksgiving. We'll probably just do a session playing around with multi-chain. And then we have a day-long event scheduled for Saturday, January the 30th, here at Gangplank, which will be from 9 a.m. to 6 p.m. with a mini conference in the morning, break for lunch, form teams, and come back for a hack session. So I'm going to wrap it up with that. Greg, I want to really, really thank you for your time and being so generous to speak with us directly today, and hopefully this will be the start of a continuing conversation where we can contribute to what your passions are, and we'll have some sort of collaborative flow going here. So thanks, Greg.
Yeah, thank you all for having me. It was an awesome pleasure chatting with you guys.
All right, thank you. Have a good night.
You too. Take care.